When the forces are unbalanced, if you have 11 newtons to the left and 10 newtons to the right, then what happens if the pull on one end is greater than the pull on the other? Then there's a resultant force, and in this case we'll calculate it, and it's equal to 11 this direction, 10 this direction. It must be an overall force of 1 newton to the left, and it's going to move to the left. And so it says down at the bottom here, if you remember, unbalanced forces, what do they do? Or when forces act on an object, what do they do? They lead to a change, and this change could be in direction or speed. So in this case, we are going to have a change in direction because it's going to move to the left, and also you will have a change in speed. So because there's a greater force here, it's going to cause it to accelerate. Forces and motion. If an object is stationary and an unbalanced force acts on it, it will start to move. So in other words, if there are unbalanced forces, you'll have a resultant force and it will cause it to move. If an object is moving and an unbalanced force acts on it, there are three possibilities. So if it is already moving, it will speed up, it will slow down, or it could come to rest. Because that unbalanced force could be a braking force slowing it down, make it come to rest. So it could also come to rest. Starting moving. An object will only start to move if the forces applied to it overcome any frictional forces. For the examples shown, say if the stationary objects will move or not, and if they do move, say in what direction. So again, this was an animation, and there's wee arrows on it just to show you the direction of movement. So in this box here, you've got a push of 50 newtons to the right and a force of 20 newtons to the left. So when you have a push of 50 newtons to the right and a force of 20 newtons to the left, overall you've got 30 newtons. Starting moving. An object will only start to move if the forces applied to it overcome any frictional forces. For the examples shown, say if the stationary objects will move or not, and if they do move, say in which direction. So you can see P stands for push, F stands for friction. Again, this was an animation, so there's a little arrow beneath it, and this was just to play. So if there's a push of 50 to the right and a force of 20 to the left, then overall there's going to be 30 newtons, and it's going to move to the right. The next one here, there's a push of 20 newtons to the right and a frictional force of 20 newtons to the left, so it will not move. The forces are balanced. And the third one here, there's a push of 100 newtons to the right and 20 newtons to the left. So overall you're going to have 80 newtons, and it's going to be moving to the right. Now, the last wee bit which we would have mentioned in class is terminal velocity and air resistance. We know that air provides resistance to motion when an object moves through it, and this is called air resistance. And we've already mentioned that the faster an object moves, the greater the air resistance. Now, eventually, no matter what object you're talking about, whether it's a car moving along a road or a parachutist as shown in the diagram here, eventually the force in one direction equals the force in the other. Now I'm going to do it in reference to this parachutist, but it could be a car on a road where you've thrust forward and air resistance backwards. So I'm going to write in force down, which is of course weight. Well, the force upwards, which is air resistance, will increase and increase and increase until it's equal to the weight. So that's air resistance. Now, when that happens, we have a situation of balanced forces. Therefore, the forces are then balanced. And balanced forces, Newton's first law. So we've two options, either the object's at rest. Now, the person's not going to stop in mid-air, so that's not a feasible option. But the second option is that it could be moving at a constant speed or velocity. And when that happens, we call this terminal velocity. The terminal velocity, it depends. The terminal velocity of different objects depends on two things. First of all, their weight, because obviously it depends on the weight and then the amount of air resistance against it. But the second thing is, of course, shape. So the parachutist falling without the parachute will have a much higher terminal velocity than they will have when they open their parachute, and that makes sense because that hugely increases the air resistance. Eventually the two forces become equal to each other and they fall much, much more slowly enough so that they can land safely.